morning, class. How are you guys doing? Good. Excellent. Okay, let's start by reading the learning goal. Brock, would you mind reading the learning goals for us and the scale?
Of course. Students will be able to differentiate and integrate a function. Students will be able to do 4 is develop a strategy to evaluate derivative and integral. 3 is to differentiate and integrate a function. 2 is use models to evaluate the derivative and integral. 1 withheld, success at level 2, and 0 is even withheld, no success at level 1 or 2.
Okay, so I'd like to take like 10 seconds, 15 seconds to discuss what each of those levels mean, the scale. So if you can turn to your partner. Okay, wrap up your thought, please. Okay, on your note card, which will act as your exit card for the day, please go ahead and rate your current level, either the 0, 1, 2, 3, or 4, and then also explain why. Right next to it, why are you at this level? Thank you. Okay, so I'm seeing a lot of 2s, 3s, and a couple 4s, which is excellent. So that's a great starting point. So let's begin today by reviewing a little bit of what we did yesterday with the E to the U, with doing a Kahoot game. So if you guys can all take your cell phones out or your technology devices and log in, please, for me. Now, as you recall, Kahoot is a game that records speed and accuracy. So let's see who our top player is today. Ready? I love technology. So the first one, what is the derivative of e to the u? 2e to the u. You get 12 seconds. Two seconds, and your time is up. And the correct answer is your circle. 10 of you got that correct, so excellent job. Let's go over it for a moment. We have 2e to the u, and I'm asked to take the derivative of that function. So who can help me here? Brock?
You're going to use derivative e to the u equals e to the u du.
Good.
And then, so you're going to write 2e to the u, so that's du. And then derivative of u is 1.
Perfect. Do we have any questions? So let's see how we did.
Yeah. Good job.
Pretty impressive. Okay, integral. E to the 3x minus 1. Remember, the question is up here if you can't see it. This one you have a little bit longer. You got 60 seconds for this one. I like the little questions that pop up. That one's a good one. Trigger happy or true genius?
True genius.
Okay, exactly. Okay, time is up, and the correct answer is the green one. Ooh. So, okay, let's think about this for a moment. What ones can you eliminate without doing any work? Why? Plus C. So this would be my careless mistake. Because you knew it's an integral. Integrals have to have your plus C unless it's a definite integral. So we only were down to these two. So looking at this problem, what property are we going to use? Okay, yes. We're definitely going to use substitution. But where does this come from? What is the property, the identity that we learned? Yes. Perfect. So we're manipulating these two problems. So I'm going to let u be 3x minus 1. Therefore, du is 3 dx, because I'm taking the derivative, and I'm going to match. Bless you. I'm good with my x. I'm missing this 3. So I'm going to give it a 3. And this is where those of you that picked this one made that like careless error. When you put that 3 on the inside, where does it go on the outside? As a what? 1/3. As a 1/3. So I have 1/3 integral of EU du. I have matched it to my property, and now I can apply my property. Don't forget to transfer back in on your actual work. Let's see how we're doing. Ooh, we have a new leader. Try this one. This is an Algebra 2 review. Okay, so we had a little bit of a time issue with that one, didn't we? Okay, so we have 7 equals ex plus 1. ln of both sides. Because whenever you see a property of an e, you want to get the exponent down, we take the ln of both sides. So we have ln of 7 equals x plus 1, e, ln of e, which goes to what? 1. Remember the little trick. If you look how I write it, it kind of looks like a 1. So we can eliminate that, and we have ln of 7 minus 1 equals x. Questions? Yes?
Why is it ln of e at the end?
Okay. If I ln both sides here, right? What about that power property? Where can this guy go? In front. So that'll give me that ability to get rid of that ln of e. Because the entire reason why we do this is to bring that power down, so we can use that property. Okay, let's see how if our leaderboard changed. Yeah. Okay, last one. How'd we do? Hey, pretty good. We're still having a little bit of knowledge issues on the time. The timing is getting some of us. So what are we asked to do? Integrate or differentiate? Differentiate. So I'm back to that same property we talked about earlier. Where the derivative of e to the u is e to the u du. So I'm going to rewrite it. And I'm going to take the derivative of my exponent. What's the derivative of my exponent? 2. And I'm done. Good?
Yeah.
Let's see who is our class winner.
I've been up there for a while.
There you go, see? Do we like the Kahoot games?
I guess.
Yeah. Okay, go ahead and put your phones away. And let's talk about the material we're going to cover today, which is going to lead into this. So today we're going to be talking about section 5.5. Which are bases other than E. So let's talk about some review items from Algebra 2. We talked a lot about the exponential functions in Algebra 2. We talked about the function y equal to a to the x. Let's see what we remember. What is any value raised to 0? 1. And then a to the first is equal to a. This allows me to be able to sketch what my graph is going to look like. Just like yesterday with the e to the x, this one just changes the a each time. It's not a constant value of a. So I'm going to plug in these points. When x is 0, I get 1. When x is 1, I get some value of a. So I see my basic exponential model. These are important because when we go to like chemistry and biology and we start talking about half-lives, and we start talking about decay of organic substances, and we're actually trying to figure out when they are going out of your system, mercury deposits, that's what these graphs model. They never really go away. That's why they only approach 0. They have that horizontal asymptote there. Because once you have a chemical or have a substance there, they can't just disappear. It has to go slowly away. Other properties you learn. A log ax. When you have the same a here is the same base here of the log, what happens? They cancel each other out, and you're left with x. Written the other way, we're back to that same property with the ln's. When we have log raised to a power here, where can this x go? To the front. When you have the same a here as the a here, what happens? It cancels off. That's that ln of e, the little 1 trick, and we're left with just x. You also learn change of base. I call this like a little alligator. You're in like your little alligator mouth, and then chomp chomp. So you read across, and then you read down. You get log b, log a. Why this is important for calculus is we're not going to change it to log base, like log base 10 here. We're going to change it to log base e, which is otherwise known as ln, because I know how to take the derivative of ln. I know how to integrate, well, I know a method for integration for ln, but I don't know the formula for log b, just for any log. So that's why we convert to log b, which you did on your little quiz yesterday, when you rewrote it as ln of the top over ln of the bottom. What about the domain and the range here? For which one?
The domain.
Correct. because basically all real numbers, because every number can work on their domain. But if we're going to be able to apply this to real life, apply it to accounting, apply it to chemistry, we can't have this go past 0. Because we're talking about half-lives, how it keeps on breaking down. If you start with 100 to something, you divide by a half. That's 50 of it. Then 25, then 12.5, and it keeps on going down. But you're never going to get to nothing of it. That's why the half-life concept happens. So it goes from 0 to infinity along your y-axis. Do you remember any of that from Algebra 2?
No.
It's okay, you can be honest, yes.
Yeah, but how come we don't use a bracket at the infinity?
Because you can't capture infinity, because there's never an end for infinity, so we always just use a parenthesis. So this is the knowledge that we've already learned. Now let's talk about today's properties. Today we are working on derivative of a to the u, because we want to be able to find the maximum. We want to be able to use these models and find logistic growth. We want to be able to find the max and the min when we're setting these functions equal to 0. Does it look similar?
Yeah.
Looks like e to the u. This one is a to the u, ln of a du. Let me compare it to what we did yesterday. Yesterday we did derivative of e to the u, which is e to the u du. 20 seconds. Turn and talk to your partner and tell me if you can come up with an idea of hypothesis of why this is different or why they're the same. Okay, so Brock, I saw that. What did you think?
I thought because ln of e, well, ln e is going to equal 1, so it's not going to be in the e equation like it is in the a.
Exactly. Because it's the exact same thing. The only difference is that e is a specific value and has to deal with log base e. So ln of e here just goes to 1. So you actually already learned this. Now we're taking and applying a specific case to a generic case. Look what happens for the integral of a to the u. And let's compare it to e to the u. Once again, we see that same concept happen. The difference is that when this is not e, you have to have that still change of base idea to it. Something had to have happened to this. So let's try some examples. So I'm going to give you the function y equals 3 to the 2x. And I want you to find the derivative of it. So which property am I talking about? 1 or 2? 1. They ask me to find the derivative, because remember, y prime is just another way of writing the communication of derivative. So let's try it. I'm just going to use this example, this model, to figure out what this is happening. So in this case, a is 3, and 2x is my u. So I rewrite, just like e to the u, just rewrite the start. Now I'm going to multiply by the ln of my a, which is ln of 3. And then I'm going to multiply by the derivative of the exponent. That's what that du part means. So what is the derivative of 2x? 2. And that is my solution. Okay, take out your whiteboards, please. Let's have you try one. So same directions. Let's see if you can use this model and do your own. So y equals 5 to the 4x. you lift them up and show me? Excellent, you all got it right. So great job. Now, back to your learning goal for today in your scale. That would be like an example of a level 2 that you can use the model and you can actually evaluate this. So let's try the next level up. So let's do example 3. Yeah, you already have the answers. You guys want me to write the answer for you?
No.
Done.
Do you write this in our notes?
You only need to do the ones that we're doing on the board, like the 1, 3, 5 ones. You don't need to do this one. Okay. So now we're going to go back to what we learned in chapter 2. And we're going to apply these new things. So basically all we're doing is, you've already learned how to take the derivative. You know how to integrate. I'm teaching you new properties to make it easier, to actually make you be able to answer all of the questions on your AP test. So this is asking you to find the derivative of y equal to 2 to the 3x times x squared. And you also have the GCF out. That means it needs to be in simplified form. That's where the algebra comes into place. How are you going to take the derivative? I know, I'm sorry. The product rule. So what's the little saying for product rule? Good. So first, derivative of the second plus second derivative of the first. That's our product rule. So for that, here's my first, and here's my second. So let's do this one together, and then we'll try another one on our own. I'm going to recopy my first. So 2, 3 to the x. What is the derivative of x squared? 2x. Plus the second. Now, I need to use my property, because that's a to the u. So you okay? Okay. So I rewrite 2 to the 3x times ln of 2. And then what's the derivative of that exponent again? 3. So the calculus step is really over. So we took the derivative. I know. Are you guys okay on the calculus step?
Yeah.
Nod, respond. Okay. Now let's factor. Bad word. I know, bad word. I see this guy in both spots. I'm going to pull him out. I also see this x. And there's 2 there. But that's the only thing I see common in both locations. So I'm going to take out how many x's? 1. So I have 2, 3 to the x times x. So this corresponds with that 2 to the 3x. And this corresponds to the x. Now I'm going to see what I have left over. From the first part, from my first ds, I have a 2. Drop my sign. This is out. I only could take out one of those, and these are still remaining. And I have my answer. Any questions? Does the color help? Yes.
Why didn't you distribute the x to the ln and the 3?
You couldn't distribute it. You mean like that?
Yes.
Because it's not addition. It's multiplication inside. So had that been a plus sign, then we would have been able to distribute it. But why also can't we take this 3x and put it with that 2? We could bring it to the numerator. I mean, we could bring it to the exponent like that by using that property, which is what they might do on the AP test. Because remember, we had to match those multiple choice questions. They could like mess with you that way. They could even from there make that 3x like that. And then what would 2 cubed be?
8.
Then they could do this as well. So you have to be prepared to do those algebra things that you know. More than likely, they're going to leave it like this. But there is a chance that they could actually do that and you can match your answers. So let's try another one on your whiteboards. The 3 is here. The x is from the 1x here, and then the ln of 2 is from what's left over here. Okay, this one. So we have y equals 3 to the 4x times x to the third. Okay, your algebra steps look, your calculus steps look really good. The hardest part is always the algebra step, I know. Excellent. Excellent. Great. Right. Excellent. Delaney, that's great. Ooh. How many x's did you pull out?
1.
What's your derivative of x cubed? You just need to add that.
Yeah.
Just add that 2 to that 3x. There you go. Okay, the calculus looks really good, guys. Can you hold up your answers now? Excellent. It's okay. Perfect. Well, then you'll need a 2 here, right there. You're almost there.
4x ln of 3.
Yep, perfect. Good job, guys. Okay, we have one more to go over before I let you guys work on getting from that level 2 to level 3 of trying some on your own. Let's talk about the integral. We have the integral of 2 to the x dx. Now I'm going to be using my other property. I'm going to be my a to the u. So I'm going to be looking at here, and my a is the 2. So I get 2 to the x over ln of 2 plus c. That's it. I know, it looks like all of them. It's just the process. Yeah. Had it been anything more complicated, let's say we change this to a 2x. Then we would need to use our u substitution to go through it. That's okay. Okay, so what I want you guys to do now is I want you to work in your partners, and I want you to practice some AP questions. So get out your AP multiple choice questions. Nope, you can go ahead and write. We'll go over it. And on your derivatives drill number 1, I'd like you to do 3 and 18 and 20. Let's try those 3 problems. And you guys have like 3 minutes. Okay? 3 minutes. So work together. 3, 18, and 20. Derivatives drill 1.
Oh, okay, I got you. That's 1, 2, 3. Oh no. Like that, you have to do chain rule, right? And bring
Yes.
it down.
Yes, I know. It's scary. How are you gonna start it? How are you gonna start it?
I was gonna include that property.
Correct. Product rule. Yes.
The X is implied there, right? There's just an X there. So you use
No.
product rule?
It's chain rule. But you're not doing that one. You're doing number 3. It's derivatives drill number 1, and then you're gonna start at 3. Remember, there's 3 pages of derivatives drill. What's it called?
I'm thinking. The drop rewrite one less. Okay.
Train rule. Yep.
For the E, is your position in LN?
Remember your E is a to the u. Derivative a to the u, so just be rewrite it times the derivative of the exponent.
Oh, okay.
Does it say 1 through 3?
Like number 3. You're doing derivative drill number 1, 3, 18, and 20.
Does the square, is this first derivative second derivative first?
Chain rule.
Chain rule. Is this the first derivative second derivative first, or am I wrong about that?
Yeah, first yes. So how do you take the derivative of sine squared 3x?
I take out the 3, right?
Do chain rule. Well, yeah, you'll multiply it by 3 because that's the du part. But you need to do the drop, rewrite, one less.
Yeah, that's the thing. Why is there an extra 3?
What's the derivative of d in the angle?
Inside.
Correct.
Everything makes sense. I always forget.
And then hyphen.
That's okay.
You can rewrite sine squared 3x is sine 3x in a parentheses.
Right, so drop it.
Yeah, why wouldn't you do like product? Oh.
Because how do you take the derivative of sine cubed squared 3x? To take the derivative of that second, you have to do chain rule. So you have to drop it, then rewrite it.
But what did that have to do product? Yeah.
Well, you're starting the product first, so that 2 isn't there yet.
Okay. Because I did ET,
So erase this 2 right there, yep.
So
So that's your first.
first,
Now we need to take the derivative of the second, so we get 2
2
sine
sine
3x.
3x
Now what's the derivative of sine?
cosine.
Cosine, yes.
Want to keep the squared?
No, because that's gone.
Okay.
Cosine of 3x. Now what's the derivative of the angle?
What's the angle? The 3x would be 3.
Right. Now do plus.
Second derivative of the first.
Correct.
Okay. Mister, did I get this to this x or like both x? Okay.
Both x.
Both x?
That's what you get.
A, B, B. So what we're doing, is that looking relatively right?
Yeah.
Yeah?
So look at answer choice A,
Oh, wow.
and you have it.
I am frankly surprised.
Why are you surprised? You shouldn't be surprised. Okay, 30 more seconds.
Is 3 number N?
Yep. How are you gonna do that one?
Particle.
Is that a product? Isn't that just a coefficient?
Which is pretty.
Well, do you need to? Because isn't that just a constant? E squared? Just a number. So don't you just take that's a constant?
That's just a derivative?
Yep. So you have E squared.
Okay.
That's just a number. That's like 2 point whatever squared. Then what's the derivative of ln?
Whatever. Yeah.
That's it. Nope. This is
Okay, so
a number.
right, it's a constant.
Correct.
Oh, not general. It's like normal. Oh, you're right.
So is this a constant?
It just so happens to be yes.
Yes. So you have E squared, and then what's the derivative of ln?
Yeah.
Yes. Number 20.
Yeah.
What's the derivative sign?
Cosine.
Cosine of pi, right?
Cosine.
What's cosine of pi? You forgot your cosine of pi here.
Oh, okay.
Okay, so we need to wrap this up. So it looks pretty good. A, B, B. So I'm pretty sure you all got that one right, minus the 20. So let's quickly go over 20. Yes. So 20 was y equals e sine x. So we're back to that concept of a to the u still, but it's a special case, the ln of a, ln of e here. So we rewrite. And then we take the derivative sign, which is cosine of x. The trick here was that we had to plug in pi. So we have e sine pi times cosine of pi. Think back to your curves. Cosine of pi is -1. Sine curve is 0. So e to the 0 is 1, because anything, that's what we started today with, was 1. And we get to 1. And then 1 times -1 gives me my -1. Okay, what I would like you to do now is go back to your note card. And I would like you to write where you felt like you're now at. Are you at a 0, 1, 2, or a 3, or a 4? But also tell me why. What did we do today? Because this is your exit card for me that made that growth happen for you. If you didn't grow, if you didn't change, if you maintain like a 4, I understand that. But what could I do to help you? What would be the next step that I could provide for you instruction-wise to make you make that next growth? Because remember, our goal is to get to the 3. Okay, thank you very much. And if you guys want to just leave them on your desk, and I will collect them as you leave. Have a good day.